we are the Avengers, and our project is called Fusion. And hopefully we'll reveal why we're calling this project Project Fusion as we get started. So first of all, to introduce ourselves, we have 3 people from Assemble. Do you want to forward the slide? Thanks. My name is Nancy Brown. I'm a national account manager with Assemble and also an architect. I'm based here in the state of Washington, in Spokane, and have worked in the technology industry for the past 8 years. So I transitioned out of practicing architecture on a day-to-day basis and into the practice of software technology with Autodesk, and then transitioned to Assemble just a couple of years ago. And with me today is Jason Jackson. Jason is a senior software engineer with Assemble, and Quentin Davis, also senior software engineer with Assemble. And with us from New York City is Amir Tasbihi. Amir is a senior BIM manager and project control specialist with STV Group based in New York City. Forward. So the problem that we are trying to solve today is a problem that many of our customers have, actually. And that is that there are a number of efficiencies in construction delivery based on isolated islands of information. So the construction management process has various knowledge areas, and those knowledge areas generate different work processes and also different activities that reside within different software programs. And those software programs very oftentimes don't integrate, don't talk to one another, which makes it also very difficult for collaboration to happen. So those discrete islands of information don't talk to one another, and certainly they don't integrate with BIM. And so BIM, very oftentimes, after the pre-construction process, is sort of thrown out. It's not leveraged or utilized further downstream into the construction delivery process. So that is a problem that we at Assemble are always trying to solve, but it's also part of the context for our hack today. Who has this problem? Well, number one, owners are really challenged by this problem. They obviously want the best possible product for the least amount of money, and the efficiencies in delivery directly impact their bottom line. It also impacts the construction industry and also impacts software developers and vendors. So that's obviously a problem that we're trying to solve. Why are we trying to solve this problem? From the perspective of BIM, we're trying to ensure that BIM is actually leveraged for the robust data that it has in it. And we're trying to integrate that data from other areas into BIM too, so that it can be leveraged throughout this process. And the best person to create a problem statement for us is one of our customers. So I'm going to turn it over to Amir, who is going to speak to a particular context for our hack today.
Thank you. Let me start with just introducing a little bit about, talking about a little bit about STV. So STV is a full-service company working in different areas, including construction management, design, building facilities, transportation infrastructure. And we have around 1,500 employees with different offices around the country. And what I can say is that when we talk about the islands of information, we are talking about ourselves. We are talking about us. We are the ones who are stuck in those islands of information. And what we have been looking for is basically we have a lot of data, and we have been doing this job for a very long time. Like, our company has been active for more than 100 years, and we have a lot of data. We have a lot of expertise. But the thing is, all of that data cannot be efficiently integrated. A lot of the people that we know in construction industry, from the owners, from the different parties, they don't have efficient access to the data. And what we see, the trends that we are seeing in the market is a lot of people, because the companies like us are not seeing our needs being addressed through the software companies and different things. A lot of companies are starting to have R&D, and they are doing their own integrations and those kinds of things, and which seems to be reasonable. And this is exactly what we are doing in order to integrate the different packages. Can you go to the next slide? And what we needed to have, and what the need that we have felt through the years has been a software that should be that is cloud-based, because we need to. I don't need to have something like a desktop application and I want to talk to the owner, say open Revit or open the other software or all the different applications and go to that menu and do this and do that. It would be a little bit too complicated for a lot of the people, a lot of folks in the construction industry. They don't have that expertise. So what we have to do is to have some sort of cloud solution. I will give them a user and password. They would go on the website and they will navigate through the model and do a lot of things. This is basically what we use Assemble in some of the use cases. We need to have access to, we have a lot of the different software packages like P6 and cost estimation software and all of these different things, but everything has to be integrated with BIM for us. And the most important thing is we needed something to enable us to do our integration. We don't need another software. It's just something that we thought might be doable with what Assemble has. We need something to enable us or other software developers to work around and do something around those kinds of components. And I think we thought maybe Assemble has a lot of the things, but if some things are done, it could open a broad area for us. That's why we work with Assemble. And for the first step, we thought that might be a good concept, but for the first step, we started from schedule, which is the most critical point maybe in anything in project management, because when you have a schedule, then you have costs, you have a lot of different things that are somehow attached to the schedule. We can bring all of that data into the BIM environment, like the critical path, color coding for critical paths, like the look-ahead schedules that we have in construction, like the 4D simulation that we do in other software packages. But if that is done through the web, then a lot of other people can go and see the project for themselves. They can go back and forth in time and see the project and how it is constructed and see the critical path, what objects are in the critical path, and things like that on the web. And eventually, what we were supposed to do was to compare planned versus actual schedules we get in a meaningful manner. And a lot of more people, not just the tech-savvy people, should have access to that data. Now, I will let Quentin talk about the details of how this was made possible in this hack.
The first detail was magic. So a lot of the times, you'll see products like Google Maps and things like that where they have their data up in their cloud, and you're like, oh, this is a really awesome map. I'd really like to use that. That was totally the wrong time. But a lot of times you see things like Google Maps, right, where you're like, oh, I love this map. I'd really like to use that. And people like Google, they made it available, so then you can embed it in your web page, and then you can put layers on it, do other things with the map, and that sort of thing. And folks like Amir, one of our customers, he had a need where he saw lots of different pieces of data that they had, and like, oh, I'd totally like to be able to take that data, combine it with this data, and put it over here on this web page. So what we did was he had Primavera where they had scheduling information, and then he saw the 3D model viewer that we had where they had uploaded their Revit models. He said, I'd totally like to take both of those and put those together, but at the time it wasn't very easy. So that's what happened this weekend, was we took both of those pieces of data and we combined them into a third piece, or a third application. Part of it was we had to first unbundle some of the stuff from our product so that we could embed it into something for folks like him and pull the data out of Primavera. So go to the next slide. To do that, this is one of the bonus points. For this, we started out, the WebGL view that we have, the architectural model viewer, is built in WebGL. The whole product is obviously HTML5, or not obviously, but it is. And during the hack, what we did in building the standalone web page that integrated our viewer along with the Primavera data, we frequently were running into various problems, so we wanted to just look out on the web, find whatever open source projects we could that we could pull in to quickly do something and that sort of thing. So we used a lot of the obvious sort of things like jQuery. A lot of people use jQuery for DOM manipulation. We had Backbone and SlickGrid. SlickGrid's not necessarily obvious, but we had to have a grid. SlickGrid's really great. It's very slick. Obviously, we're using REST to make calls back to get the data. We were like, oh, we wanted to show some scheduling, as Amir was alluding to. We wanted to be able to see the model change over time and that sort of thing. We said we'd like to have a slider. We went out and looked on the web, found a really great slider called JQ Range Slider, which was really awesome. It looks very attractive. You throw that in there, and it made a lot of things very easy. And we had other little problems where we're pulling in the date from Primavera, and the date times that were inside of Primavera weren't easily parsable by the engine that is used inside of JavaScript. So we used that, and it helped parse the data. So we'll go ahead and Did you have anything else, or we go to the demo? Okay, let's go ahead and go to the demo.
So as Quentin described, I mean, one of the key things that we did here was allow the model viewer to be embeddable, which means that our customers, such as STV or other customers or other software companies, can actually embed the viewer to connect with any kind of data source that they wanted, so, or that you want to connect to. So in this case, we chose to use the data source from Primavera because it's very robust, a lot of data. As Quentin referred to, it's got tasks with the beginning start date, actual start date, actual finish, budget, etc. So we pulled in the data that we thought would be useful for the prototype. In this case, we've got the activity ID, whether it's critical or not, activity name, start, finish date, budget, the selection, so selection in terms of number of components that are selected and assigned to that activity, and then various, and then being able to assign the components. So the key part is being able to, or the first part was being able to select components from the viewer. So Jason is actually going through, selecting the components, assigning them to a particular task, and then they are color-coded based on whether they are critical or whether they're non-critical. And so various objects can be assigned to various components based on where they're supposed to be in the schedule. You'll notice that it's kind of dark with the background screen, but he is just going through and clicking. So we're making a call to the mobile, to the viewer app, and enabling that interaction with the 3D model. So this obviously doesn't require any modeling skills. Somebody doesn't have to know how to model, know how to use Revit, know how to use AutoCAD to be able to do this. They can simply be sitting at their web page on their laptop and be applying the tasks to the modeling components. Did I miss anything? Oh, the next aspect.
And I guess it's not real obvious because it's a little bit washed out here, but we're showing the critical items in an off red, and then just the other items kind of in just a little bit of a shaded model color.
That's right, and then the components that are gray are those components that have not yet been assigned to an activity. So there is a way of, and they're automatically being color coded by whether they're critical, non-critical, or unassigned. So go ahead and move into the simulation. Now, in addition, additional criteria for STV was to be able to show the objects over time, obviously in simulation. So you see the slider bar at the top, which has 2 dates and 2 ranges. So you can either show a time period and what is happening during that time period, or you can show the accumulation of activity over time.
And you can't see it on the washed out screen, but the whole building is here ghosted. You know, if we were in a dark room, you'd see that the whole building is actually there. So you have context for these things that are just kind of magically appearing in thin air.
And it's full screen. So notice that the grid has disappeared, it's full screen, and you're interacting with it dynamically over time. So with that, any last comments, Amir?
So just one comment, which is, so basically this has what is known as 4D modeling, fully on the web, without any need of any desktop application. And not only that, you can actually simulate the critical path. And other than that, actually the slider that you see on the top, you can view the look-aheads, so you can actually play with the range of the data that you have, and you know what activities are happening within that range. And also you can go back and forth in time to view the 4D simulation. So it has 2 functionalities in one: viewer fully on the web. And the other thing that I just wanted to mention was the viewer component is so optimized because there are a lot of viewers on the web, and some of them free, some of them whatever. But not all of them, I think a very limited few of them can handle huge models, sophisticated models. This is one thing that we have tested. That's why we were interested in this, because this works with really significant type of models. So when you have a lot of elements, it works well. So that's another point that I just wanted to add.
So for the future, we didn't get to driving the activities with the Assemble quantity engine. We have, we pull all the data from models, and so the next step for us is really to add the quantities and cost, which is data that we have. We just didn't get time to integrate it into this process. So we're really excited for the next steps with this, and we're really excited that we've been able to decouple, or what I'm calling disassemble, assemble, so that we can actually allow others to engage their data sets with us and take this even further. So thank you.